Hello ATS 113 students, Dr. Shragi here. I was informed by a couple of the students that you don't quite have all the information that you need about the Hurricane Cookbook in order to answer a couple of the questions on the homework set. And so to facilitate answering those questions and to keep us from getting too far behind in the lecture, I thought we'd just have a quick little video that illustrates the concepts of the Hurricane Cookbook, and this will be a nice way for you to review for the test as well. Okay, we talked about the fact that there are a total of 6 ingredients in the so-called Hurricane Cookbook. If you don't have all of these ingredients, you're not going to get a hurricane. One of these ingredients was high sea surface temperatures, at least 26 degrees Celsius, which is something like 80 degrees Fahrenheit. And that is because you need to have a strong, I wrote on here, flux of sensible and latent heat. The strong the high sea surface temperatures promote a lot of evaporation, and you need to have all that evaporation so you can transport water from the ocean into the atmosphere to replace the water vapor, which is condensing out and forming liquid water at an incredible rate in a hurricane. That being said, hurricanes don't actually seek out the warm water, by the way. They just, if they happen across warm water, they'll strengthen. If they happen across colder water, they'll weaken. Hurricanes aren't somehow smart, and they can avoid the cold water or something like that. Your second ingredient of the Hurricane Cookbook was the Coriolis force. We said that basically because the hurricane is in, on this slide it says they are in cyclostrophic balance, but they're not quite in cyclostrophic balance. They're actually in gradient balance, as we talked about today in class. In order to be in gradient balance, the hurricanes need to be at least maybe 5 degrees of latitude off of the equator. What does this tell us? It tells us that hurricanes can't form at the equator and hurricanes cannot cross the equator. Hurricanes form in areas that have low stability. They have instability. They're not stable locations. This rules out the subtropical highs. I know a couple students after class had this wrong in their notes. They had that hurricanes do form in the subtropical highs, but they don't because of the sinking motions in the subtropical highs. Subtropical highs are very stable, which is not going to be a good place to create thunderstorms, and we're going to need hundreds of thunderstorms if we're going to make a hurricane. All right, now, an important feature that you do need to know about the Hurricane Cookbook is the fourth ingredient, which tells us that there needs to be no wind shear in the environment around the hurricane. Remember, wind shear is this business as to how winds change with respect to height. Hurricanes hate wind shear. I like to tell students hurricanes are just made of air. They have a lot of structure. They have an eye that has to have an eye wall around it, and the eye wall has to be sloping according to the stadium effect in just such a way. If there's wind shear and the top of the hurricane is blowing one way and the bottom of the hurricane is blowing another, we're never going to get the right distribution of latent heat release and condensation to create the structure we need in a hurricane. Therefore, what does this tell us? Hurricanes never form near the jet stream where there's a lot of wind shear. They will never form near fronts. By the thermal wind relationship, fronts have a jet stream above them. So you often hear during hurricane season that a cold front is going to sweep a hurricane out to sea. No, there's no such thing. When you have a cold front, there's going to be a jet stream above it, and the hurricane's not going to form or not going to be able to cross that area of wind shear. So no wind shear is an important ingredient in the Hurricane Cookbook. Okay, you need to have high values of relative humidity in the middle of the troposphere. Not necessarily down near the surface you have to have high humidities just because you need to be over the ocean and things like that. But in the middle of the troposphere you're going to need some high values of humidity because this is going to reduce the impact of entrainment. Now I talked about entrainment earlier in this unit of the course with regard to thunderstorms. Hurricanes are made up of hundreds of thunderstorms. These thunderstorms need to have as little negative impact from entrainment as possible. Let's show you an example. Okay, here's some kind of thunderstorm it was supposed to be over the ocean, although I see now that there seems to be some kind of power tower or phone tower or something in the background of this picture, but that's okay, it works just fine. So here's a little thunderstorm developing maybe over the ocean or something like that, which means that it has a rising air parcel, an updraft in it. And this updraft needs to be strong and robust. It needs to last long periods of time if this is going to be a strong, mature thunderstorm that's going to be able to be part of a hurricane. But no matter what, around the outside of this rising air parcel, there is the process of entrainment. Air from outside of the updraft is mixing into the updraft. And that air around the updraft is going to be cooler than the air in the updraft. I mean, that's why the updraft is rising, right? It's warmer than the air around it. And it's going to be drier than the updraft. That mixing of dry air from the environment into the rising updraft causes evaporation of raindrops, which is a cooling process, which changes our updraft into a downdraft. For a while, we'll have both an updraft and a downdraft. But eventually, we'll actually have a weak, if any, updraft and a strong downdraft. This is not favorable for a hurricane. We need a big, healthy thunderstorm that's not going to be affected all that much by entrainment. Right, so eventually, we'll just have a downdraft. It'll still be producing precipitation, but this storm is doomed. What we need then in the environment around the thunderstorm is cold, moist air. Cold, moist air is an important part of the Hurricane Cookbook. Cold, moist air at mid-levels of the environment reduces the impact of entrainment. See, now as air from around the environment, around this updraft, if this entrainment from the environment around this updraft happens, which it will eventually happen, the air that you're bringing in from the environment is moist. It won't really cause that much evaporation of raindrops, so there won't be that much cooling of the updraft, and the updraft won't be so quick to turn into a downdraft. So that sounds like a good thing, right? We're reducing the impact of entrainment by having the air that comes in from the outside be cold and moist. Now you might think, well, why don't we use warm and moist air then? If the air in the environment was warm and moist, then we would be mixing that air in the environment into our rising air parcel. It would be neither making the updraft cold nor dry. Sounds like a good thing, but actually it'd be a bad thing. If the environment around this air parcel was warm, there wouldn't have been rising motion in the first place. So unfortunately, that doesn't work. All right, your final ingredient in your Hurricane Cookbook is an initial disturbance. An initial disturbance is an area of unorganized thunderstorms, just sort of a random mess of thunderstorms, which will get organized into a tropical storm and maybe a hurricane. Hurricanes don't just happen. Hurricanes don't start as a small hurricane that grow into a bigger hurricane. They start as an unorganized area of thunderstorms and become a much more organized hurricane. Typically, these thunderstorms are going to actually be squall lines that moved off the coast of Africa. Don't worry about the rest of what it says on that slide. I thought I'd just show you an example. Okay, here is off the coast of Cuba and Puerto Rico. Here's just a really unorganized area of thunderstorms. This is not a hurricane. This is not a tropical storm. There's just sort of a mess of thunderstorms. There's a group of thunderstorms, but they're not very organized. A few days later, though, that unorganized area of thunderstorms can have become organized into a hurricane with an eye and an eye wall and an outer rain band. All right, so this is a good example of how you need an initial disturbance to form a tropical storm or a hurricane. Okay, I hope this quick little overview of the processes that are part of the Hurricane Cookbook has helped you. If you have any questions, please feel free to contact me. This has been Dr. John Schrage, copyright 2007.